Hi kids, now we'll be going with this paper discussion. You can look into the very first question. The first question says, infinite number of conducting spheres, each of radii r, are arranged as shown below in the figure. All the spheres are initially uncharged, switch S1 is closed. After some time S1 is open and S2 is closed. Thereafter S2 is open and S3 is closed. This process is continued till the last switch is closed. Find the loss in energy. Loss in energy in the sense loss in electrostatic energy through the entire process. So what's happening here? This is what is happening. Initially the figure is like this. All switches are open. Thereafter this is closed. When this is closed, what will happen? This will be getting charged Q. Till when? Till the potential becomes equals to V, because this is 0. The potential difference has to be V, right? So KQ by R equals to V. That I have. Okay, I didn't. Okay, I have written it here. So the charge will be in such a way that KQ by R will be V. Now what will happen? Now both are of equal radius, so I don't have to bother much. Like when I open this switch, the charge is going to be Q. When I close this, the charge will be equally distributed because equal potential. Equal potential in the sense equal charge because the radius is equal. Now I will be opening this, I will be closing this. What will happen? Q by 4, this Q by 2 will distribute as Q by 4, Q by 4. Now I will be opening this and I will be closing this. Then it will become Q by 8, Q by 8. Right? So it will keep on happening. So Q by 2, Q by 4, Q by 8 and so on. Right? So this will keep on going on. Now what will happen? Whenever there is charge, there will be self energy, right? And it is a conductor. So whenever there is a conductor, the charge will come only onto the surface, right? So there will be a spherical shell kind of thing. So what is the self energy of spherical shell? KQ square by 2R. So we'll see. What is the work done by the battery? Charge given by the battery is Q. So work done by battery will be Q into V. Work done by battery is Q into V. Energy stored in the first sphere. What is the charge on the first sphere? Charge on the first sphere is going to be Q by 2. So self energy will be KQ square by K into charge square by 2 times of radius. Now the next one will be having charge Q by 4. So self energy will be K into charge square by 2 times of R and so on, right? So this is the work done by the battery. Out of that, this is stored as electrostatic potential energy. Where is the leftover? Leftover will go as heat. So you need to find what is the work done by battery, what is the electrostatic energy stored. The difference is going to give you heat, right? And here I solved in terms of Q, but we need in terms of V. So from there Q will be V into R by K. So I just substituted Q as V into R by K. Then you will be ending up with the answer, right? The next question is the distance between two solid conducting spheres. See, conducting spheres, whether they are solid or hollow, whatever charge you will be giving, it will be coming onto the surface. It's much more than their radii. So basically they will be saying like when you calculate potential of this guy, don't bother about its influence. That's the thing. The spheres are connected by a cell using conducting wire as shown in the figure. Find the electrostatic force of interaction between spheres. Now why there will be force of interaction in the first place? There will be a potential difference, so charge will be coming onto the surfaces. Now these two are isolated, so summation of these two charges must be 0. So what I can do, I can say charge on this one is Q, charge on this one is minus Q, but the potential difference has to be V. So what is the potential on this guy? Potential on this guy anywhere will be same, which will be same as the center. So this won't be affected much by this one. That's what they said, because the distance between them is large. So what will be the potential? KQ by R1. What will be this guy's potential? K into minus Q by R2. What is the difference? K into Q by R1 minus K into minus Q by R2. The potential difference has to be V. From there I will be getting the value of Q. Now why I am getting the value of Q? Because they asked what is the force of interaction between them. What is the force of interaction between them? KQ1 Q2 by distance square, and it is going to be attraction, right? K into Q1 Q2 by distance square. Both charges are same in magnitude. So this is what they asked to find. But what I did, I need Q value. So I found Q value from here. I will be just, this is the main question, but I don't know Q value. In order to find Q value, I said the potential difference will be V. So from here I will be finding Q value, and I will be just substituting it. I will be getting the required answer. Now the next question, the below diagram shows the symmetric arrangement of 3 identical rings of resistance R. Okay, resistance R they have taken, but I think the actual question was 3R. Anyway, that doesn't matter much. Find the effective resistance between C and D. So imagine there is some battery connected between C and D. You can see there is symmetry. So you can see there is symmetry, and yeah, you can calculate the angles and stuff also that I have shown you here. If I join these three, the distance between these two is R, these two is R, because this is center and this is the circumference of that yellow thing, right? So this is R, this is R, this is R. So angle will be 60. Now if the angle is 60, this will be 1/6, right? 1/6. This will be 1/6. 1/6. So this one will be 1/3, right? Sorry, half of the total resistance. Okay, fine. Anyway, I didn't bother much. I have taken it as smaller. Now the thing is, there is some resistance here by symmetry. I mean, I can draw the charge current distribution and I can show you like the charge. There won't be current in this one and there won't be current in this one. That you can figure out easily. Now that's not the thing. Now after removing it, when current is not flowing in this and flowing in this, whether I put them or whether I remove them, battery doesn't feel any different. So I'll be removing them and I'll be drawing the figure. Now I call this as R. If this is R, this length is also same, this length is also same, this length is also same. Now all this I am calling it as R. If all are, these are 3R, this is going to be 3R because it is 3 times of that, right? So this much everyone can manage, but from here you need to find what is the equivalent resistance between these two. Now I can show you like it is symmetrical about this axis, or else I can show you like these two potentials will be same, these two potentials will be same. So I can say like this and this will be in parallel. So R and R will be in parallel, which will become R by 2. This R and this R will be in parallel, which will become R by 2. This 2 will be in parallel, R by 2. These 2 will be in parallel, 3R by 2. These 2 will be in parallel, R by 2. So I'll be drawing the figure like this. Now there is some imaginary battery. Now it's pretty, I have pretty space to draw it. So I have drawn it. But this is not balanced Wheatstone bridge. There is a problem. So how I proceeded it is, I assume the potential here is X, potential here is Y. Then I have utilized the T-shaped figure. Now, if you don't know what is T-shaped figure, I have taken in the revision. Yeah, kind of. You can refer to this kind of thing. So when there is T-shaped kind of thing, I'll be assuming the midpoint potential is higher potential. So I'll be writing this outgoing current plus this outgoing current plus this outgoing current must be equals to incoming current, which is 0. So that's the same thing I have done. This outgoing current plus this outgoing current, this plus this outgoing current equals to 0. I have written this outgoing current plus this outgoing current plus this outgoing current equals to 0. I have written. Now there are only two variables X and Y I assumed, so I can solve for those two equations and I'll be getting the value of X and Y. Once I got the value of X and Y, I'll be just substituting it and I can find the current in this, I can find the current in this. So this current is V minus 2V by 3 is V by 3, V by 3 by R by 2. This current is V minus 5V by 9, which is 4V by 9 by this resistance is R by 2. So I'll be getting the current in this, summation of these two will be the current in this. So current delivered by the battery is this much. Now, when I know the current delivered by the battery, if I want to find the equivalent resistance, I need to do V by I. Finally, I calculated V by I. This will give me the resistance. But when I substitute the value, now what is my small r? See, in the actual question, total resistance is 3R. So, but for me, it is like R, 3R, total is 6R. So, in the actual question, it was 3 times of capital R, but for me, it was 6 times of small r. So small r equals to capital R by 2. When I substitute it, I'll be getting some other answer. Actually, in the solution, there was something wrong. They have taken this resistance value in a wrong manner. This resistance value. So they got the wrong answer, right? The next question, in the below circuit, the capacitor is initially uncharged. Find the charge in the capacitor after closing the switch. Now this one you can solve it using integration as shown in the solution, or you can use Thevenin's theorem. Now Thevenin's theorem was taken in revision class. Again, if you don't know, most probably you'll be knowing it. It's like, if there is a load, if you want to find the current in the load, or if you want to find any characteristics in the load, if the remaining part of the circuit consists of only resistors and batteries, what you can do, you can replace it with a single battery and single resistance. Now how to find that resistance? If you want to find that resistance, short circuit the battery, find the equivalent resistance across the load. And how to find the V Thevenin? It's like open the load and find what is the potential difference across the load. We'll be seeing the same thing here. Now if I want to find R Thevenin, what I need to do? I need to short circuit this battery. I have short circuited. I need to open the load. Now across these 2 points, what will be the equivalent resistance you need to find? That will be, these two will be in parallel, which will be 4 into 1 by 4 plus 1, 4 by 5. And then these two will be in series plus 2. So R Thevenin will be 14 by 5. Similarly, if you want to find V Thevenin, you need to find what is the potential difference across this one. No current will be flowing through 2 ohm. So this potential difference will be same as this potential difference, which will be same as this potential difference. If I want to find this potential difference, I need to find the current in this. Current in this is 12 by 5. So resistance is 12 by 5 into 1. I into R. Potential difference will be 12 by 5. So V Thevenin will be 12 by 5. So I can replace V Thevenin and R Thevenin with the load, right? Now this is simple circuit, right? Do you know how to solve this circuit? The charge will be of this form, where tau is R into C. Right. where Q naught will be how much? Q equals to CV. Finally, like it will be fully charged, right? C into this V. So everything is fine. The only thing is, if you use Thevenin's, the things are going to be easy, or else you have to do integration. Now the next question, find the amount of charge that has to be spread uniformly on the surface of soap bubble to double its radius at constant pressure. Initial radius of the bubble is R, surface tension of the soap is T, and atmospheric pressure is P naught. So radius is doubling, volume will become 8 times. If volume become 8 times, there's a constant temperature. So P into V is constant. If volume becomes 8 times, pressure will become 1 by 8 times. Now, anyway, this is the soap bubble initially. Initially, if the inside pressure is P, outside pressure is P naught. When I draw the free body diagram of half bubble, there will be inside pressure force, which will be P naught into effective area will be pi r square. Outside pressure, actually the pressure force will be in all the directions, but effectively when you integrate it, it will turn out to be P into effective area. Effective area is the shadow of this guy. So inside pressure force will be P into pi r square, outside pressure force will be P naught into pi r square. Apart from that, there are two interfaces, so there will be two surface tension forces. One is T into length 2 pi r, the other one is T into 2 pi r. Now this is in equilibrium, so I can write net force equals to 0. That's how you will be deriving 4T by R formula, right? So when I make net force equals to 0, I'll be getting outside force must be equals to inside force. Inside force is this one plus this one. That's the first case. Now when the bubble has blown up, radius is increasing. Radius is becoming twice, volume will become 8 times, pressure will become 1 by 8 times. So this force is going to become, inside pressure is going to become P by 8, right? P by 8. P by 8 into effective area. Outside pressure force will be P into effective area. Now why it has increased its size? Because you have charged it. When you charge it, what will happen? The charge will go on to the surface. When the charge goes onto the surface, there will be repulsion, there will be electrostatic pressure. Now again, electrostatic pressure, if you don't know, most probably you will be knowing. If you don't know, again it was taken in revision class, how to get it in a easy manner. So it will turn out to be simple, like half epsilon naught inside electric field square minus half epsilon naught outside electric field square, or as it is a sphere, you can go by this way also, where you will be ending up with sigma square by 2 epsilon naught. That's up to you, right? So sigma square by 2 epsilon naught into effective area I have taken, but while using that equation, I'll be going with half epsilon naught into inside pressure square, inside pressure square inside electric field square minus outside electric field square magnitude wise. So okay, these are pressure forces. There will be electrostatic repulsion force, and apart from the surface tension force. Now again, I'll be making net force equals to 0. When I make net force equals to 0, this is sigma square by 2 epsilon naught. I have written it in the other way. Half epsilon naught into outside electric field square into effective area. Pressure into effective area, right? Now this is this pressure force that you can see here. This is this pressure force, and this is this surface tension force. Now those are the two equations we need to write. Now we need to solve them. Now how I have solved it? P I substituted from here, right? P I just substituted it from here and I solved it. Then okay, then what's it? Nothing much. It's about only solving, right? It's about only solving and get the value of Q. So the only important thing is how to write these two equations, right? So if you write these two equations and if you eliminate P, you will be getting the required answer for Q, right? The next question. In the following infinite circuit, R1 equals to 2 and R2 equals to 1, find the current through R1 in the 10th segment. 1, 2, 3, so 10th segment. So in all these kind of questions, we'll be finding the effective resistance in the first place. So how we'll be finding the effective resistance? We know, like, so if we assume that the equivalent resistance is X, that is from here to infinity, then we can say like from here to infinity also it is X only, because the structure is going to look same, right? So if the equivalent resistance from here is infinity, here to infinity is X, from here to infinity is also will be X. So if I replace this entire green color thing with a single resistance, I'll be getting this figure. If I replace this entire yellow thing with a single resistance, I'll be getting this figure. But I know these two figures are same figure. So what is the resistance here? These two are in parallel, so 1 into X by 1 plus X, and those two are in series plus 2. But I know this equivalent resistance must be same as this equivalent resistance equals to X. When I solved it, I got the equivalent resistance as some 1 plus root 3. Now when I know the equivalent resistance, I can get the current, right? Current will be potential difference by equivalent resistance. So anyway, I didn't write it, but I am assuming it as I. Now if this current is I, it will split into two parts, I1 and I2, such that this potential difference will be same. So I1 into 1 equals to I2 into X. I1 into 1 equals to I2 into X, but I know the total current has to be I, right? I1 plus I2 equals to I by KCL. Now when I solve it, I will be getting I2 as I by x plus 1, and okay, I2 is I by x plus 1. Now what is I2? I2 is the current in this one. So current in this one will be I by x plus 1. That's what we got, right? I by x plus 1. Yes. So if the current coming is I, current going here is I by x plus 1. If this is I by x plus 1, this will be I by x plus 1 by x plus 1, right? So this whatever this current by x plus 1, whatever this current by x plus 1, whatever this current by x plus 1, whatever this current by x plus 1. So you can see a pattern. So it will become I by x plus 1 whole power 9. This is the first segment, second segment, third segment. So this will be the 10th segment. But what is current? Current is V by resistance. Resistance value is root 3 plus 1 we calculated. When you substitute, you will be getting the required answer. In the next question, in another world, instead of Coulomb's law, the electric force on a point charge Q due to another point is given something like this. Okay, where alpha is a positive constant. Electric field due to, so if force is given, how to find electric field? You need to just divide with Q, right? So this is going to be right answer because this by Q is this. Now line integral of this electric field over a closed path is 0. Now line integral in the sense you need to integrate it. You need to calculate what is the work done. So you need to take dot product with dr and you need to integrate. You can see like when you integrate, first term is dependent on R, second term is also dependent on R. So integration also is going to depend on R. So it depends only on the initial and final position. Or when you go in a loop, it is going to become 0. So B is also correct. So if B is correct, then D is going to be, I mean, if the integral in a closed loop is 0, if the integral in a closed loop is 0, it is conservative force. But in the option D, they are saying it is not conservative force. So option D is going to be wrong. Now if you look at option C is going to be wrong because Gauss law and Coulomb's law are equivalent to each other. That is, when the force is inverse square nature, only then Gauss law will be valid. Now first term will be inverse square in nature because this R bar I can write as magnitude into direction. That magnitude and this magnitude, one magnitude will get cancelled. First term will be inversely proportional to R square, but second term is not going to become inversely proportional to R square. So Gauss law is not going to be valid, right? Electric field will be force by charge. Integral will turn out to be line integral will turn out to be dependent on only initial and final position. So it is a conservative force. Coulomb's law and Gauss law are equivalent. That is, when the force is inversely proportional to R square only, you can use Gauss law. Now the next question. The point charge Q, the point charge capital Q, is having mass capital M equals to 2 times of small m. It is tied to two identical charged particles, each of charge small q and mass m. The length of each string is L and they are inextensible. The system is held at rest on a smooth horizontal surface with string taut in a position where the strings make an angle 60 degrees with each other. Select the correct options. So what will happen when you leave like this? All are having charges, so there will be repulsion between these two, but tension, that string is going to become tight and so it can manage. But there will be repulsion due to these two, so what will happen? These two will try to go up, these two will try to go up, but when these two try to go up, there will be tension which will be pulling it down. Now, how can we understand this? When there are three objects moving, it's always better to view from center of mass point of view. Now the net external force is 0. If the net external force is 0, center of mass is going to, it's not going to accelerate. If it's not going to accelerate, it will go with the same velocity which was initially, which was 0. So center of mass will be stationary. No matter what is happening here, center of mass will be stationary. What does that mean? We'll see. Center of mass of this system, center of mass of these two particles will be here. Center of mass of, that is 2m. So center of mass of these two will be exactly at the center. This distance you know, right? So all those stuff you can calculate. From there, option A and D I have directly written. So what are option A and D? Amplitude of oscillation. Amplitude of oscillation will be, what will happen? So because of repulsion, these two masses will be coming out like this. This will be coming down. So after some time, it is going to look like this. Now this will be having some speed and this will be having some speed in the downward direction. But net momentum initially was 0. Finally also it must be 0. So if this momentum is P, this momentum and this momentum will be P by 2. That I can guess by symmetry also. Right, now what will happen? This will go down and it will come to rest, and this will go up and it will come to rest. So whatever is this figure, this inverted figure will be coming in here into picture. So this 2m will be going this much distance as well as the same distance here. So it will be oscillating with this much. Now that much length is going to be option A because it is equilateral triangle, right? So then maximum speed acquired will be at the mean position thing, right? And they are asking tension, total mechanical energy is conserved. Yes, total mechanical energy is conserved because tension won't be doing any work and all the other forces are conservative forces, so mechanical energy will be conserved. Now from here to here, why the speed came into picture, there will be a drop in potential energy which will be converted into kinetic energy. Now I'll be writing what is the initial potential energy. Now potential energy between these two and these two charges won't change, but because the distance between them is remaining same, potential energy between these two charges is alone going to change. So I'm going to write only potential energy between these two charges. Now what is the potential energy between these two charges? Kq square by L. Now what is the potential energy between these two charges finally? Kq square by 2L. Kq1, Q2 by R, right? So there is a drop in potential energy. Where it will be going? It will be going as kinetic energy. So kinetic energy of this guy is P square by 2 times of its mass, P by 2 square times of by 2 times of its mass, momentum square by 2 times of its mass. So that I can get only single variable if I write in the terms of momentum. So finally I can solve for momentum P. But what is P? P is momentum of this guy, that is 2m into velocity of that guy. Velocity of that guy I can find, which says option B is wrong. Now tension you need to find. Now if you want to find the tension, you can write this guy is performing circular motion at that moment, right, with respect to center of mass. So you can write net force towards the center equals to mv square by r. Now how many forces will be acting on this? Tension, and there will be repulsion force because of this charge, and there will be repulsion force because of this charge. T minus kq square by 4l square, that is force between these two, minus force between these two, k small q capital Q by L, equals to mv square by r. Net force towards the center equals to mv square by r. Now this velocity, right, but we need to calculate what is that velocity, right? And that you can do. P by 2 equals to m into v, that you can do. Or if this velocity is v, then this velocity is also going to be v, and this velocity is also going to be v, because momentum is 2mv, right? If this momentum is 2mv, then this momentum mv. So this velocity will be v, but you are observing from this point. This point is already having velocity v. So when you observe from this point, then its relative velocity will be 2v. Actually this velocity is v, this velocity is v, this velocity is v. So you can see total momentum is 0. But you are observing from this charge, so this velocity is going to be 2v. So with respect to this guy, with respect to 2m, this m is performing circular motion. So you need to observe from this guy. When you observe from this guy is moving constant velocity, so no pseudo force. But this guy is moving some velocity, so relatively this guy will have velocity 2v. Net force towards the center equals to m into relative velocity square by radius. So when you solve it, you will be getting the required answer, because v value we have found, right? We just need to substitute v value, then you will be getting the tension. Next question goes like, the hinged non-conducting rod is shown below. The rod can freely rotate in vertical plane about the upper end. The charge per unit length of the rod varies. For half the thing it is positive charge, for half the thing it is negative charge. If there is electric field on the positive charge, the force will be in this direction. On the negative charge, force will be in this direction. But they said it is in equilibrium, so it will try to rotate it this direction. This will try to rotate it this direction. Torque due to this guy and torque due to this guy must be equal in magnitude, opposite in direction. So that's the only thing. So what we'll be doing, we'll be taking some element. When I take some element, the force on this element will be q into e. Q will be lambda into dy. At a distance y, I am taking dy. So charge will be lambda into dy into e. But for this guy, what is the lambda? A y square. Now similarly, if I take negative charge at a distance y, now that charge will be lambda dy. Charge into e will be force, that will be in this direction. But what is that lambda? Magnitude wise b into y, and direction I have already considered, right? Because of negative charge, force will be in this direction. Now torque because of this guy and torque because of this guy, I mean this total torque and this total torque must be balanced. Now if I calculate what is the magnitude of this total torque, that is perpendicular distance into force. Perpendicular distance into force. Now what is the torque because of this force? Perpendicular distance into force. So I can say like this total torque must be equal to this total torque, magnitude wise equal, right? Direction wise anyway we can see like they are already opposite. Both torques, perpendicular distance into force. Perpendicular distance into force. Now integration from 0 to L by 2 for this guy, L by 2 to L for this guy. When you do the integration, you will end up with some integration. Now this L power has to be same, so from there you can conclude n equals to 2. Once you conclude n equals to 2, you can substitute it back, and you can see the only relation is A and B are left. You can substitute n equals to 2, then only A and B are left. From there you can get the relation between A and B. Now apart from that, they are asking some other stuff. the force applied by hinge on the rod and the horizontal component of force by the hinge on the rod. Okay, so we calculate torque, but we need to calculate what is the net force also, because you can see mg, there is mg, which will be balanced by hinge force. Now apart from that, there is some horizontal force. We don't know net will be in which direction. Let me say net is in this direction. If the net is in this direction, then hinge must provide force in this direction. Only then net force along horizontal will be 0, right? Net force along vertical can be 0 because hinge can provide mg. Now if the net force along horizontal has to be 0, hinge has to provide some other external horizontal force. If I want to find that, let me calculate what is the force acting on this and what is the force acting on this. How to find the force acting on it? Find the force acting on any one element and integrate it. How to find the force acting on this? Find the force on any one element and integrate it. When I integrate it, force acting on one element is this, and yeah, 0 to L by 2. This is the total force on the positive charge, 0 total force on the negative charge. When I calculated the difference turned out to be this much. So which is more? It turned out to be positive. The meaning is force on the positive charge is more. So force is going to be on the total thing, electrostatics force is going to be this way. So hinge force is going to be this way, and magnitude wise how much? Magnitude wise this much. But I think in the solution they have something said like this is almost, I mean in the question something is missing, I guess. So they said this is mg. Anyway, still it's strong answer, so we don't have to bother, right? So suppose this force is also mg, then what is the horizontal force? Horizontal force provided by the hinge is mg, but the net force is going to be root 2 mg. Next question goes like, the radius of inner shell in below figure is r and the outer sphere is 2r. Q is charge given to the inner sphere while the outer sphere is grounded. A point charge Q having mass enters from outer shell and radius and all the stuff are given. So basically they are asking what is the radius of curvature immediately and with what speed it will be hitting. So anyway, it's grounded. If it is grounded, like I can show you, the outside charge is going to be 0. This will be Q and this inside charge will be minus Q. Anyway, the field inside will be given by only this guy. This inner induced charge won't be producing any field because it will be like symmetrical distribution, right? Like shell. So when it enters, velocity is going to be this way and there will be attraction force in this way. Now if you want to find the radius of curvature, what you need to do? You need to resolve force along the velocity and force perpendicular to the velocity. Along the velocity, it will act like tangential force, and this will act like centripetal force. So what is the centripetal force? Force by root 2, right? So this is the force K, Q, Q1, Q2 by distance square. Force cos 45 or yeah, 1 by root 2. So net force, centripetal force equals to mv square by r. From there you will be getting the what is the radius of curvature. Now that's a straightforward thing. Now when it is hitting this, what is the speed they asked? So you can go with energy conservation, right? So all the charges won't be affecting, only this charge will be affecting. So when I take the potential energy between these two charges initially and kinetic energy, so initial kinetic energy plus initial potential energy equals to final potential energy plus final kinetic energy. You can see like initial potential energy 2r, final potential energy r. So you know u, right? Yeah, they have given u. So you need to find v. So all you need to do is just solve the equation, get the value of v, right? The separation between neutral spherical conductors shown in below figure is large. The initial switch S1 is kept closed and S2 is open. Now S1 is open and S2 is closed. So again it's the same pattern, right? So what you are doing, initially you are closing this. When you close this will be getting a charge Q till when? Till the potential is going to become V. So KQ by 2A is V. From there I can get the value of Q. So that's the first step. Now what they are doing, they are opening it and they are closing it. What will happen? Some charges will start flowing, right? Charges will start flowing. So I assume some charge, I am calculating like what will happen after the full redistribution happens. Charges will start flowing, but I am looking once the steady state is achieved. So out of Q, X stayed here, Y stayed here. So X plus Y is Q. Now apart from that, till when they will be flowing, till these two potentials will be same. What is this potential? Kx by 2A. What is this potential? Ky by A. So till these two potentials are same, the charges will distribute. Now this is a situation finally. So what is the value of Y and X? You'll be getting the value of Y and X. Two equations, two unknowns, right? So you can solve for them. You can get X value and Y value, right? So that is the final charge on this sphere and final charge on this sphere. These are easy questions. What they asked? They asked some other thing. total heat generated after closing S2. Total heat generated after closing S2. That is, there was some electrostatic energy on this. There is some electrostatic energy on these two, right? But there is some heat, obviously, like charge is flowing, right? So how to find that heat? I can find the electrostatic energy on this one, and I can find the final electrostatic energy existing, and the difference is must have gone as heat. So what is the initial electrostatic energy? K q square by 2 times of its radius. K q square by 2 times of its radius, self energy, right? Now self energy of this guy, k x square by 2 times of its radius, k y square by 2 times of its radius. X value and y value we know. K x square by 2 times of its radius, k y square by 2 times of its radius. This is the initial energy, this is the final energy when you are subtracting whatever left over. Whatever we are getting here, what is that? That must have gone as heat, right? Now they are asking some other thing. It's like the rate of fall in potential at any time. So we need to go with some generalized situation. What is that generalized situation? This was the initial situation. Now after some time t, I mean after I close, after some time t, let me say charge on this one is small q, so charge on this one will be minus q. What will be the current? Current will be the rate at which the charge is accumulating, that is dq by dt. So potential difference equals to I into r. I have written kq by this radius is this potential, kq by this radius is this potential. Potential difference equals to I into r. Now this I is d small q by dt, right? Now when I write this equation in a modified way, I'll be getting this. Actually I have to integrate it, but what I did is I can see it is going to look like this is some constant, and yeah, in this particular question kq by 2a is v also. So it's quite okay if I replace it with v. Now this is like q by c form, this is I into r form. This is going to look like your familiar charging circuit, right? In charging circuit, current is going to be this form. Current will be of this form, where tau, what is tau? R into c. You can do that. But what they asked? They asked rate of fall in potential of sphere of radius 2a. So you need to find what is this potential and at what rate it will be falling. What is that potential? K into charge by 2a, what rate it will be falling? Minus k by 2a, whatever it is, dq by dt. This dq by dt is nothing but the current. You can find it from here and you can substitute here, right? Yes, then I think you will be ending up with the answer, right? So you can integrate it if you want, or else you can compare with your well-known equation and you can solve for it, right? Next one is the below figure shows two small identical metal balls, again metal. So the charge will be coming onto the surface. The balls are connected by light conducting spring of spring constant K and natural length L. L is much greater than R. Uniform electric field is switched on and the horizontal direction. The magnitude on the charge of the magnitude of charge on the balls when the distance is L, and the system fails to oscillate, okay, as the ball moves out the magnitude of induced charge. So initially it is like this. Now when you switch on electric field, what will happen? It will try to attract the positive charges and repel the it will try to attract the negative charges and repel the positive charges. So this is going to become negatively charged, this is going to become positively charged, and once it becomes negatively charged, like it will be attracting further, so it will be extending its length. So at any moment when this moves by, this total extension is x, where this will move by x by 2 and this will move by x by 2. Yeah, so the total extension is x, so the total length is L plus x. I have written it here. Now at any moment, like these two potentials will be same. So when I equate those two potentials, what will happen? They are at very large distance, so you don't have to bother with potentials between these two. Now potential of this guy is K into its charge by R. Now this potential must be same as this guy's potential. This guy's potential will be KQ by R because of its own charge. But there is electric field. When there is electric field and electric field is in this direction, so force on this guy will be in this direction. So it's like gravity. So you can visualize like gravity, right? So when it is in the direction of force, when you go away, potential will be reducing. So this guy will be having less potential. How much less? E minus E into distance between them, right? So you have seen gravitational potential, right? If the distance is h, like if I take this as 0 reference, this will become minus mgh, right? Minus mgh. So in the direction of force, potential will be reducing, or else you can, if you want, you can go with minus E bar dot dl bar and stuff. So anyway, this is the thing. Now from here I can get q as a function of x, and when the x is increasing, q is increasing. So that gives option D as wrong, because when the distance is increasing, charge is increasing. Now when x equals to 0, that is going to be initial situation. That's what they are asking in option A. When x equals to 0, then you will be getting the charge as 2 pi epsilon naught whatever stuff, right? Then I'm trying to write the force on this. Now the good thing about the question is the net force is going to be 0, spring force is going to be internal force, and electrostatic force on this guy will be q into E and q into E. So center of mass won't be moving. Anyway, that has nothing much to do with the question. Now if I write what is the net force acting on any one guy, net force acting on any one guy will be spring force and electrostatic force, right? I mean, you don't have to bother about force between these two because L is large, they said. So now you need to bother about electric field force, because now if I talk about this guy, there will be spring force in this direction, but there will be electric field force in this direction. So the net force will be spring force minus that electric force, right? Spring force minus that electric force. That electric force will be q into E. Q we have calculated, q into E equals to mass times of acceleration. Acceleration is the rate at which this displacement is varying. So x by 2 whole double dash, right? So from here, when I modify, I'll be getting some equation like this. This will be testing our equilibrium position only. I know acceleration or x double dash is proportional to x, so it will be SHM when this is going to be positive value, right? Because we are pulling it this way, it has to pull it in the opposite direction. If I put the directions also properly, this is going to become minus of stuff. So if this is greater than 0, or if it is positive value, it will be performing SHM. So only under this case, it will be performing SHM. Now in the last option, they said k value is more than this. K value is 4 pi epsilon naught r. So in that particular case, what will happen to the effective this value? This is like omega square, right? Omega square into x in it is SHM. Effective value will turn out to be this much. Then yeah, omega, not omega square. This is like, yeah, force. Force is some k into x form, right? Like spring constant into x form. This is m by 2 into x double dash. You can look like SHM form and then you can solve for it and you will be getting the answer. That's fine. So all you need to do is just put it back. You can remove this because it will be testing only the equilibrium position. Then you can see it is going to look like SHM. The below figure shows two large identical thin conducting plates A and B. The plates are placed parallel to each other at small separation. Charge is A is given Q, another plate is placed whose charge is 3Q. The distance of C from B is twice that of from A. A and B are joined by using connect wire. So till it is not grounded, the charge on these things will be conserved. So in the revision class, I have taken I can have shown you like the outside charge is going to be half of the total charge given. What is the total charge? Total charge will be 4Q. So outside charge will be half of the total charge, 2Q and 2Q. Now I assumed this charge as x. If the charge is x, this charge is going to be minus x. So if the charge is x, this is total 3Q. So this charge will be 3Q minus x. Now if this is 3Q minus x, this will be minus of 3Q minus x. Okay. Now that much you can manage. Now this distance is D, this distance is 2D. Basically this potential difference will be same as this potential difference. That is Q by C here equals to Q by C here. X by C. What is the capacitance? Epsilon A by D. Now this charge is 3Q minus x by epsilon A by 2D. So from there when you solve it, you will be getting the value of x. When I substitute the value of x, I will be getting minus 2Q plus 2Q, Q and minus Q. So this much you can manage. From there you can get all the options A, B, C, D. Okay. There are some grounded things also. Let me see. Charge appearing on the ground. Okay, if you ground, what will happen? If you ground, only the outside charges are going to become 0, but the inside charges are going to remain in the same manner. So when you ground it, only the outside charges are going to become 0. The inside charges are going to remain in the same manner. So it won't be affecting the answer. Electric current through a conductor varies with potential difference across it according to the relation. The conductor is connected with resistance R in series with cell and stuff. The power generated in the conductor is twice the power generated in the resistance. Now what they have given, they have said like these three are connected in series, and yeah, they have given I equals to A into V power half. So V is, yeah, A value I have substituted, V equals to 25 I square. So the potential difference is 25 I square. So what is the energy taken by it? V into I. And they said this power utilized equals to twice of this power utilized. So 25I cube, like 25I square into I, V into I, 25I cube equals to 2 times of this power. This is one equation. Now the other equation is potential difference, net potential in the loop must be 0. So when I do that, this 6 equals to 25I square plus I into R. Now all we need to do is solve for those two equations and get the value of R. Net voltage in the loop is 0 and the given condition power in one equals to 2 times of power in the other. Consider potentiometer circuit arranged. AB wire has length 300 centimeters. The jockey touches at 275. Then the current flows through the galvanometer you need to find. So this is the given figure, and before that they have given rho into 300 centimeter by A is 2LR. So I am finding like what will be the resistance of length 25 centimeter and 275 centimeter, which turned out to be R and 11R. So basically this is 11R and this is R. Now what I'll be doing is, generally I have to write loop equation and I need to solve it, but when I write loop equation, it doesn't matter whether this potential difference will come first or this potential difference will come first or this potential difference will come first. So what I can do, I can interchange them. I can put this guy here, I can put this guy here, or I can put this guy here and I can put this guy here. So what I'll be doing, I'll be pulling this guy and I'll be putting it here, and I'll be pulling these two resistors. So basically I'll be changing the order. Because I know I'll be converting everything to that T-shaped figure which I have shown you earlier. So when I bring these two up, it will become 2R. When I bring this battery, it is going to become E. Now similarly, I'll be putting this resistance here, I'll be putting this battery here. Now I'll be assuming this as 0 volt, then this will be E, this will be E, this is 0, this will be 0, this will be E by 2. Now there are 3 resistors, I have drawn it. This is 2R, this is 11R, and this is 2R. And this potential is E, this potential is 0, this potential is E by 2. Now I'll be assuming this as X, this outgoing current plus this outgoing current plus this outgoing current equals to 0. From there I'll be getting the value of X. Once I get the value of X, I can do anything. What they asked what is the current in galvanometer. Current in galvanometer is current in this resistance. What is the current in this resistance? This is X, right? X minus E by 2 by 2R. X minus E by 2 by 2R. X value I found, I just need to substitute and get the answer, right? A smooth parabolic wire track defined by relation y equals to x. Electric field is given. Release it from rest at some position and you need to find what is the speed at some other position. Now this is a very familiar equation. I know it is going to be conservative. It was taken in revision in work energy power. If you don't know how it is conservative and how to find potential difference and stuff. Yeah, we have done in 2 ways there. But anyway, I'll be doing it directly here. dV equals, this is basic definition. So when you integrate, you will be getting the work done. E bar dot dr bar will turn out to be alpha into y dx plus x dy, because dr bar is dx I cap plus dy j cap. Now you have to integrate this. Before integrating, I can write the same thing as d of xy. So when I am integrating, I'll be taking at 0, 0, potential energy is 0. So at any x, y, potential is v. So v will be minus alpha xy. Now initially kinetic energy is 0 t, and initially potential energy minus alpha into x into y into the charge. This is potential. So potential energy will be q times of potential, right? So initial kinetic energy, initial potential energy equals to final kinetic energy, final potential energy. From there you will be getting the value of final velocity, right? The question turns out to be easy once you know this integral thing. After getting to know the integral thing, it's only conservation of energy. Now the next one, charge per unit length of 2 infinite long charges are lambda and minus lambda. They are kept parallel to z axis. With given information, the equipotential surface is a cylinder of radius. Now you can go with the solution given, or once I know it is a cylinder, like what I can do is I am trying to find at what x coordinate potential is going to become what is given potential. So at any distance x from this, there is some positive line charge, negative line charge, right? At x equals to a and x equals to minus a along this direction. So what will be the potential here? So now before finding that potential, potential, I have written it directly. Sorry. So line charge, field due to line charge will be 2k lambda by r. So when you integrate it, you will be getting, I have integrated here, sorry. Yes, you can see it here. So this is a definition, and this is the electric field due to line charge. So when you take at any reference r naught, potential as 0. So at any r, potential is v. So potential at v will be going to be minus 2k into lambda r by r naught. So this is the potential. Now if I want to find the potential here, it will be because of this guy plus this guy. Now what will be the potential because of this guy? Minus 2k lambda into log this distance. What is that distance? 2a plus x by some reference value. Minus in this, minus you'll be getting 2k into minus lambda into log this distance by r naught. That equals to given potential. I am checking like where it will be equal to the given potential. This is the potential due to first guy, this is the potential due to second guy, this is the required potential. Total potential equals to required potential. When I did that calculation, I ended up getting two values of x. So when I check it for two values of x, 1x will be lying here, 1x will be lying here. So basically if I visualize it's like a cylinder, what will be the radius? What will be the radius of cylinder? It's like the difference in these two x coordinates will give me this length and half of it will give me the radius. Difference by half will be giving me the radius. This is the easiest way of doing it for me because I'm not good at math obviously. So I don't know like how the cylinder equation is going to look like or why to mess up things. Now the similar question, there will be some charges and sphere and stuff. There you can go with, okay, never mind. In the below circuit, EMF cell is increasing linearly from 0 to 28 in 14 seconds. So at any time, its EMF is going to become 2t, right? The energy gained by 10 volt battery in this total thing. So the first thing is understanding it is going to be 2t linearly varying, right? So it's drawing the figure. If this potential is 0, this potential will be 2t. If this is 2t minus 10. Now I can see T-shape figure again. I'll be drawing the T-shape figure. I'll be assuming this is higher potential. Outgoing current plus outgoing current plus outgoing current is 0. From there I'll be getting the value of x as a function of time. Once I get the value of x as a function of time, I'll be finding what is this current. This current is x minus 2t minus 10 by 5. So what does it mean by this current? This current in the sense, this current. So basically, I'm calculating what is the work done by this battery or what is the energy giving by this battery. So from there I'll be getting the current. Once I get the current, I'll be finding what is the work done by that battery. Work done by that battery is V into I into dt integral from 0 to 14 seconds. When I do that integration, it turned out to be 0. So what is the energy given by battery? Effectively it is 0. So what is the energy taken by battery? Effectively it is 0. What does that mean? For some time it will be giving, for some time it will be taking. In the meter bridge shown, okay, everything is given there. Find the error in unknown resistor. So meter bridge and stuff you know, right? This resistance into this length equals to this resistance into this length. That is what Wheatstone bridge will be doing, right? That's how you will be using Wheatstone bridge principle in meter bridge. That resistance into 100 minus x equals to 20 into x. This resistance into 100 minus x equals to 20 into x. So from there you can get the value of Rx because x value is given. So when you substitute, you will be getting the Rx as 5, but you need to find what is the error. Whenever you want to find the error, what you will be doing, you will be differentiating it. You will be differentiating it. When you differentiate it, you will be getting drx. This is UV rule. So dr into x, Rx into dx. This is again dx. So there are two terms like drx and dx, right? So bring dx to one side and drx to the other side. This dx is given in the question 0.1, right? Error in the x is 0.1 and x value is given. X value is given, Rx value we have calculated, substitute all the values. X value is given, Rx value we have calculated, substitute all the values. You will be ending up with what is the error there, right? So which will be this value, but we must not write this because error can't be so accurate, right? So we'll be rounding it off to only one digit, 0.0, one significant digit, 0.03. 1/4 of non-conducting ring of radius R has uniformly spread charge Q into opposite quarters and stuff. So you need to find what is the potential at point A. So what we'll be doing, we'll be obviously seeing the dipole. Now potential due to dipole will be K into P cos theta by R square. Now if I take any dipole at any angle theta, this length is going to be R d theta. So this charge is going to be lambda R d theta. This charge is going to be negative lambda R d theta and stuff. So if this dipole moment is P, then the potential here will be K into P cos theta by this distance square. K into P cos theta by distance square. Now but how to find P? P is charge, magnitude of the charge into distance between them. So this is the dipole moment because this is the potential because of this dipole. Now if I want to find the total, I need to integrate from where to where, 0 to pi by 2. When I integrate, I will be getting the required answer. You just need to substitute the values. There is some relation between q by epsilon naught given in the question, right? So what is the only thing? The only thing is looking at it like a dipole, k into dipole moment cos theta by distance square. Now how to find the dipole moment? Charge on any one thing by the distance between them two, right? Yes, and that lambda is charge on this one by its length, right? Charge on this one is q and this length is pi r by 2. That lambda is q by pi r by 2.